This video covers Year 9 Maths Applied, the test preview for the statistics unit. There's some time tags in the description below so you can skip to question numbers or types. Question 1 is the frequency distribution table and we need to complete it. Frequency distribution tables are really useful if you've got massive sets of data and they help you to arrange it. There's lots of columns, but each of them do something very important. So the frequency columns for helping us calculate the mode. The fx, or the frequency time score column, helps us to work out the mean, or the average. And the cumulative frequency, or CF column, helps us later to work out the median. We use the percent relative frequency column to help us make predictions later on. So when we go to calculate these, the score is often called the x, and the frequency is often called the f. So the fx column is simply f times x. So 4 times nothing is nothing, 7 times 1 is 7, 13 times 2 is 26, 22 times 3 is 66, 3 4s are 12, and 4 5s are 20. We put that into our calculator and we get the total 131. Okay. Next, we're going to do the cumulative frequency column. Cumulative means growing, so it's as the frequency grows. So we take this 4 over here, we move it over, and we say 4 plus the next number, which is 7, is 11. 11 plus 13 is 24. And we allow that to keep growing in the same way until we hit the total. Now we don't need a total for this column or the next, and it will be blanked out in the test, but you can use that number 53 because that is also the total of your frequency column, which will become useful for you later. The last part is to work out the relative frequency as a percentage. So what you do is you go back to the frequency column and you go looking for this 4 and the total 53. And so what we're describing it is the frequency relative to the total. So 4 over 53, then we multiply it by 100 to turn it into a percentage. So this one will be 7.5%. I'll just pause the video and fill the rest out. And now that we've filled all of those out, we'll have a look at how we can actually use them. So to calculate the mean, what you need to do is you need to take the fx total and you need to divide it by the frequency total. Okay, so in other words, in this case it will be 131, so I'm taking that from here, and I'm going to divide it by 53, which I'm taking from here. Use your calculator, and that will give you the answer 2.47. Right, for the median score is the middle score. Now, imagine these were 53 numbers lined up from 0 through to 5, so smallest to biggest. There'll be 53 numbers all on the line. So you're looking for the score that's right in the middle. So what you could do is you could say 53 divided by 2 is going to give you 26.5. So I'd be looking for the 27th score. But there is a formula for this one. Okay, what you could do is you can add your total 53 to 1 and then divide by 2, and that will give you the 27th score. We need to know where the 27th score happens. So we turn to our cumulative frequency column here, and in this first one, it's the first to the 4th score that happens here, the 5th to the 11th that happens here, the 12th to the 24th score that happens here, and then the 25th to the 46th score that happens here. So it's going to happen in that column. So if you scan back over and look at the score is 3. And then the mode is the score that happens the most. So in that case, we happen to look at the frequency column because that tells us how many times each of those scores happen. We look for the highest number, which is 22, and again look at what score that is, which is 3, and that's our mode. Now, when you guys move down, there may be some questions that ask you to use the information above to answer questions. So they're asking you what the chance is that this team's going to score 5 goals in their next match. So we can have a look at the column where there's 5 goals and scan across and see that there is a 7.5% chance that that's going to happen. It's asking you, what about scoring more than 3 goals? Well, that would be if it happened, if they got 4 goals or 5 goals. So what we can do to work that out is we can just put 5.7 plus 7.5 into your calculator, and you'll find that they have got a 13.2% chance of that happening. And lastly, they're asking you to make a prediction. In that round, they only played 53 games, and they got an average score of 2.47 goals. This is saying, what about if they had played 66 games? So I know that if on average they scored 2.47 goals each time they play, and they play 66 times, then theoretically they would score 163.02 goals across those 66 games. But obviously you can't score 0.02. So we can round that down and say, therefore, approximately 163 goals. Question 2's got us filling out a basic table, but it's missing information. So we're just going to fill in everything that we can, and then we're going to turn to algebra to try and work out the parts that we don't know. So I do know that the FX column is the score, which is in this case age, multiplied by the frequency. So 2 times 4 is 8. I've got 4 times 12, which is 48. And I've also got 5 times 16, which is 80. But I've got a few unknowns here, and so what I'm going to do is I'm going to use a letter in place. So I'm going to put an X in here. I don't want to introduce the second letter if I don't have to. So I know that the FX column is going to be 3 times X, which is 3X. And now what I'm going to do is I'm going to try and work out what the totals are so that I can work my way back to work out what X is. So turning myself into an algebra robot and not thinking about the fact there's letters and numbers, they're all just numbers. I'm just going to write down what I can see. So here I've got 4 plus X plus 12 plus 16, and I'm going to collect up my like terms. So I have got 4 plus 12 makes 16, 16 plus 16 makes 32, so I've really got X plus 32 here, and I'll write that in. And then over on this side, I've got 8 plus 3X plus 48 plus 80. It's going to give me 3X plus 136, which is what I'm going to write in here. And so now I've filled the table out, and all I really need to do is work out what X is. And there's a bit of a hint for me up here. They've given me the mean or the average, and I know that the mean is going to be the FX total divided by the frequency total. Okay, let's fill in what I know. I know the mean is 4. I know that the FX total is 3X plus 136. I know that the F or frequency total is X plus 32. And now what I'm going to do is I'm just going to switch myself over into algebra, ignore that it's a statistic question, and just use the balance method to solve for x. So I'll pop that in brackets for a minute so it doesn't fall apart, and I'm going to multiply both sides by x plus 32. And what will happen is I'll end up with 4 outside of x plus 32 equals 3x plus 136. The next move is for me to expand that, so I end up with 4 x's and 128 equaling 3 x's and 136. Balance method, I will subtract 3 x's from both sides. That leaves me with 1x on this side and 128, and it leaves me with 136 here. I will subtract 128 from both sides. I'll have x here and I'll have 8 here. So I've solved for x, and now all I have left to do is to finish filling in the table. So I know that x is 8, so I'll replace that with an 8. I know that 3 times 8 is 24, so I'll replace that. And down here I can see that 8 plus 32 would make 40. And finally, if I do 3 times 8, which is 24, and I add it to 136, I'd get 160, and the table's complete. Question 3 is similar to question 2. We're going to fill out this frequency distribution table, but we've got a bunch of information and there's a lot of gaps that we're going to have to fill out. So we know that if we target this fx column over here, we know that it is the score, which in this case is the age, multiplied by the frequency, which is the second column there. So I know that 6 7s are 42, so I can fill that one in. I know that if 7 10s make 70, and I can see that 8 3s make 24. But then in the final column there, I'm really lacking a lot of information, not enough to really fill anything out. So now what I do is I look back at the original question, and it's telling me that the average is 7.17, so I'm going to have to work with that. And I'll turn to algebra here to work this out. So I'm going to assign the frequency column a value of x, and that means that if I have a look over at the fx column, this will be 9 times x, so 9x. I don't want to put a y in there because, or another letter, because then there'll be too much for me to work out. All right, now that means that if I've given those values of x and 9x, I'm going to try and fill out the totals column down the bottom there as well. And so if I add 7, 10 and 3, I get 20. So I know that down the bottom here, I've got x plus 20. Okay, so whatever x is plus 20 will be the total down there. And similarly, if I add up 42, 70 and 24, I'll get 136. So that means that I've got 9x plus 136 to make the total down here. And now what I need to do is use the information that I've got to work out what x is. And then I can go back and actually assign it some values. So now that I know that my fx total divided by my frequency total would give me the average, I'll put that down in writing. So if the average is 7.17 and I take the fx total of 9x plus 136 and I divide that by the frequency total, which is x plus 20, I should now just be able to switch off from the frequency distribution table and just solve this using algebra. So what I'll do is I will multiply both sides by x plus 20. Just give myself a little bit more room there. To bring that up, And so now my equation will read 7.17 multiplied by x plus 20 equals 9x plus 136. I'm completely ignoring the table now. I'm just going to expand this out. So that means that over the side I've now got 7.17 x's plus 143.4. So that's just the 7.17 multiplied by 20. On this side I've still got 9x plus 136. And now what I might do is start collecting my like terms. So I'm going to make a smart move here, and I will start by subtracting 7.17 x's from both sides. And so what I'll end up with is 143.4 being equal to 1.83 x's over here and 136. Now what I'll do is I will subtract 136 from both sides, and I'll end up with 7.4 being equal to 1.83 x's. And finally, I'll divide by 1.83 on both sides, and I will find out that 4 is equal to x. So now that we've got a value for x, all we need to do is go back to our frequency distribution table and fill that out. It's important you don't forget to do this. So that means that if x is 4, this one here will be 4, and 4 plus 20 is 24. So we've got that all filled out nicely. 9 times 4, 36, and then 36 plus 136 makes 172, and that question's complete. Question 4 is a little different to question 2 and 3 because this one's looking at relative frequency as a percentage. So when we go to do this, there's a number of ways of answering this question, but I think that one of the simplest ways of doing it would be to consider that the relative frequency as a percentage must total 100%. So we can write that in straight away. That means that if we've got 20 plus 30 plus 10, which is 60%, we will have 40% remaining here. But what's happening here is we've still got an unknown, okay? And so we're going to need to try and work out what that is. Now, it's quite fast to do in your head. I'll just have a look at this and say, right, well, if 10% is 2, then obviously this means that the total is going to be 20, and I might just say if 10% is 2, then 40% is just going to be 4 times that, which is 8. The problem is that you may need to actually show some working out for that, particularly if you decide to go and do methods next year. So what we'll do is we'll just have a quick think about how we might be able to demonstrate the way that we've arrived at that answer. And so we're going to have a look at it, and if we're going to write it as a ratio where we're looking at frequency to relative frequency as a percentage, then looking at the example of the 2 and the 10 that we discussed earlier, we know that we would have a ratio of 2, 10, which if we simplify that is 1 to 5. So if we now look at, it's a very messy 5. If we now have a look at the x that we're hunting down, we know that we're looking at a ratio of x to 40, okay? So we can use therefore. We're looking at x as compared to 40. We know that it must be a ratio of 8 to 40. So therefore, x is 8. And now we can fill out our columns. We've got a value of 8 in here, and if we run up our total, we'll have a total of 20. And that answer is correct. And we've also shown some working out to demonstrate our understanding. Question 5 builds on question 4, so this time they're really not giving you very much information at all. We're looking at relative frequency again as a percentage, so we'll fill out a little bit of stuff that we know. Obviously this is going to equal 100%, but even that doesn't really help us in this instance. What we do know is that 25% is going to be 10, so I'm getting that from here. 25%, it's supposed to be a highlighter, sorry. 25% represents 10. So we know that the total down here is ultimately going to be 40. But if that's not clear, what we'll do is we'll work it out using ratio again. It makes it a bit clearer. So let's say that we've got the same ratio again. We're looking at the ratio of frequency to relative frequency as a percentage. And what we can see is that we've got a ratio of 10 to 25, which if we simplify that down to a unit ratio by dividing both sides by 10, we've got a 1 to 2.5 ratio. And so what we'll do now is we'll just apply that to all of the lines as you go across, okay? So in other words, I'm going to start by applying a ratio to 5, okay? So if I've got a ratio of 1 to 2.5, I need to multiply 5 by 2.5, and so this will give me an answer here of 12.5. And if I apply that to 10, we know that's going to be 25. Now, I'm getting stuck here, okay? So running down the percentage or the relative frequency column like this, I can see that this value here has to be 37.5 because I need all of these values here to equal 100%. And once I've got that, I can start to work backwards. So what I'll do instead this time is I'll do 37.5 divided by 2.5, and that will give me the value of 15 here. And I can total that column up to give me 40, and I've successfully completed the table. Question 6 builds on question 2. This one has got multiple unknowns, and so it's unavoidable that we're going to end up with different letters. There's going to be inevitably two ways to solve this, either with guess and check or with simultaneous. I'll try to show both. But the first thing to do is to fill in the table as best we can. So we can do as much as we can. 3 times 2 would make 6, so we'll put that in. We've got nothing in the next row, so we'll leave that for a minute. 5 times 6 is 30. 7 times 4 is 28. And so now we better start filling in some of the other bits and pieces that we can. Okay, so what I might do here is I might allocate an x, and I know that 4 times x is 4x. Now I can't use x again, so this time I'll use a y. 6 times y makes 6y. If we do it like we did it in question 1, what we'll end up with is something we probably can't solve because we'll end up with a bit of a messy looking total for each. And I think we can work out what the totals are because up here they've given us the mean and they've also given us one sneaky little relative frequency, which is quite useful. Now, that means that 4 over whatever this number here is, let's call it S for example, is going to be 20%. Now, I know that 2 over 10 is going to be 20%. So instead of looking at this as 2 over 10, if I think of a equivalent fraction by doubling both, I'd get what the low score is. If that didn't make any sense to you whatsoever, the other way to work this out would be to use algebra. Call it S, and over here on a side note, we'll say we know that 4 divided by S is going to be 20%, 0.2. Okay. So if we switch these two with transposition, then we'd have 4 over 0.2 being S, and so S is 20. So again, we found that this one here is now 20. Now, if we try and find out the total for the fx column, we can use the mean to do that. Because remember, again, if I call this one t, for example, if we take that over to the side here, I might do this one in orange, okay, just so that we've got something different here to work with. We know that the mean is the fx total divided by the frequency total. So that means that 5.5 is going to be t divided by 20. And if we times both sides by 20, then t will be 110. So we know that this one is 110. And suddenly this is starting to look a little bit more manageable. We can also sort of be a bit sneaky here and just fill out a little bit more of our percentage relative frequencies, if you like, because we know that if 4 over here is 20%, half of 4 is 2, so this one's got to be 10%, and then 6 is 3 bigger than 2, so that means that this one has to be 30%. Now, let's see if we can sort out these tables. Whether you're going to use guess and check or simultaneous equations, you are going to need to create some formulas. So let's look at what this column looks like algebraically. 2 plus x plus 6 plus y plus 4 equals 20. Collect up your like terms. So we've got 2 and 6 and 4 makes 12. Still got an x, still got a y. Bit of balance method or transposition. We'll take 12 from both sides. X plus y makes 8. Right. Just move that over a bit. So we don't get confused or use a new colour. Now I'm looking at this column here. I have got 6 plus 4x plus 30 plus 6y plus 28 equaling 110. Okay, I'm going to collect up my like terms. That means that if I've got 6, I'll drop in these x's first because that's easier. Right, 6 plus 30 plus 28 makes 64. That equals 110. Right, shift those 64s over, and now I'm left with 4x plus 6y equals 46. And here is my two equations. I've got equation number 1 here and equation number 2 here. Now, to guess and check this, what I would do is I would be having a look at focusing on this equation here. I've got two numbers added together to give me 8. There's not very many combinations that will work. I've got 1 plus 7, I've got 7 plus 1, I've got 2 plus 6, I've got 6 plus 2, I've got 3 plus 5, 5 plus 3, or 4 plus 4. And I am going to just start putting them into my calculator until I get the right combination. So if I start at the beginning with 1 plus 7, then I've got 1 plus 7 gives me 8. That worked. Let's test that it's going to work on the other equation. 4 times 1 makes 4. 6 times 7 makes 42. That does equal 46. So by pure chance, I managed to get the combination right the first time round, so I know that x is 1 and y is 7. If that doesn't work first time round, because that was just very lucky that it did, then I'll just switch it round and test 7 plus 1 and check that 4 times 7 plus 6 times 1 equals 46, which it doesn't, so no, that's the wrong combination. Once you've got a value for x and y, don't forget to go back up to your table and finish filling it out. The alternative way of doing this is to use simultaneous equations. And by using simultaneous equations, if they're not whole numbers, it'll always work for you. It's just an alternative way of doing it. The two equations need to match. If you're going to use the elimination method, at the moment I've got 1x and I've got 4x's in the second equation. So what I'm going to do is I'm going to multiply this entire equation by 4, which is going to change it into 4x plus 4y equals 32. I'm going to call this equation 1 and I'm going to call this equation 2. And I'm going to write the instruction that I want to do equation 2 minus 1. So if I go and stick equation 1 underneath here, and I subtract them, then 4x minus 4x gives me nothing. 6y minus 4y leaves me 2y. 46 minus 32 leaves me with 14. Now all I do is divide both sides by 2. I find that y is 7. To find out what x is,
Could Emily Gamers and Julia
all I need to do is sub y equals 7 is sub y equals 7 into equation 1. If I just go back to the really original equation 1, it's way easier. It would become, instead of it being x plus y equals 7, now that equals 8, now that I know that y is 7, it's just x plus 7 equals 8. Subtract 7 from both sides and x is 1. So you can use either method, okay, and you'll get the right answer. Once you've done that, we need to go back to our table and we need to replace the values. So we know that here x is actually 1. We know that 4 times 1 is 4. We know here that y is actually 7. We know that 6 times 7 is 42. And now if we go hunting for these values here, I know that half of 2 was 10%. That means that 1's going to be 5%. And if 6 is 30% and 1 is 5%, then 7% is going to be 30 plus 5, which is 35%. You can double check to make sure all of that adds up to give you 100, and the question's completed.